Good afternoon. I'm Carissa Ash, and I'm very delighted to be with you this afternoon. I am from Eureka Math, and I am here to help you understand the use of a tape diagram to aid students in algebraic fluency and modeling of word problems. I am going to show you a sequence of problems, and I would like to act as the teacher while modeling the problems. Also, I want you to participate as middle school students. I want you to pay attention to my teaching decisions so we can discuss them after the modeling sequence. We are first going to look at and model the coherent strand of word problems while introducing the RDW process, read, draw, and write. So the first one that I would like to look at is from a 6th grade example. Hannah is putting in a tile floor. Okay, so we are reading each part and deciding what we can do with that. Can we draw anything? Not quite yet. She needs to determine the angles that should be cut in the tiles to fit in the corner. The angle in the corner measures 90 degrees. Okay, so right here we have a corner that measures 90 degrees. So we're going to draw our angle and indicate that with a 90-degree coating. Then one piece of the tile will have a measure of 38 degrees. So that means part of the tile that is going to go into this angle will have a measure of 38 degrees. What is the measure of the unknown angle? So this is what we are trying to find. We know that the whole angle will measure 90 degrees, and we want to know what is the unknown. Using a tape diagram, we know that the whole thing would be 90 degrees. We are given 38 of that. So we need to know, what does the rest of this measure to fit into the corner that our tiles are being cut for? So to find that, we would just use simple math. 90 minus 38, and we get 52 degrees. So using our tape diagram, I can see that my 38-degree cut tile with a 52-degree cut tile will fit into my corner that measures 90 degrees. If I wanted to model this algebraically, I could show that my missing measurement plus the 38 that I'm given is going to equal the 90-degree angle in the corner that I have. To solve this, we would subtract our 38, just like we did up here in our tape diagram. So we would subtract 38 from both sides. And again, we would get the unknown is 52 degrees. Either way, we can see that algebraically we're able to solve it just like we did with the tape diagram. Any questions on that? Everybody good? Okay. So moving right along, let's look at a 7th grade problem. Henry is using a total of 16 feet of lumber to make a bookcase. So we're thinking of how much total does he have? So right there we have our bookcase of 16 feet. The left and right sides are each 4 feet. So if the left and right sides are each 4 feet, then that tells me I have a left side that measures 4, and I have a right side that measures 4. The top, bottom, and 2 shelves are all the same length. How long is each shelf? So if we have the top, bottom, and 2 shelves are all the same length, that means of my remaining part of my 16 feet, I still have 4 shelves I need to account for. So I have 1, 2, 3, and 4 shelves that are going to make up, with my left and right sides, my 16 feet. Okay, so we think, well, if I have a left and right, measure 4 feet, that leaves me with 8 feet to be used for my shelves. Well, I have 4 shelves of equal measure, so I'm going to take my remaining 8 feet and divide it by 4 to get that each shelf is going to measure 2 feet. So using my tape diagram, each shelf will measure 2 feet. If I wanted to model that algebraically, I could make my algebraic equation out of this word problem. We have 4 shelves at an unknown quantity plus our left and right sides holding up the bookcase of 8 equal the total length of our board. Well, what would be our first step to solve this algebraic equation? We would subtract 8. Well, if you look back over at our tape diagram, what's the first thing that we did? We subtracted 8. So we are going to subtract 8 from both sides. And then our next step would be to divide by 4. If you look at our tape diagram, what was our next step? We divided by 4. So when we divide by 4, we get x equals 2. So our unknown quantity matches up with our tape diagram of 2 feet for each shelf. Does that make sense? Any questions on that? Okay, let's look at one more. Let's look at a right triangle, an 8th grade problem. Given a right triangle, find the degree measures of the angles if one angle is 10 degrees more than 4 times the degree measure of the other angle, and the third angle is a right angle. Okay, so let's go back and read, draw, and write. So I'm reading, given a right triangle. I am going to draw my right triangle. And I know it is a right triangle by coding it as such. I want to find the degree measures of the angles if one angle is 10 degrees more than 4 times the degree measure of the other angle, and the third angle is the right angle. So that means if I let one of my unknown angles equal x, then I know that my other angle is going to be 10 more than 4 times that angle. So I get 4x plus 10 to represent that angle. Okay, what do we know about the 3 angles of a triangle? They add up to be 180. So let's look at this as a tape diagram. We have one whole angle that measures 90 degrees. We have an unknown quantity. We have 10 plus 4 more unknown quantities. So let's look at this. Total, we have 100 degrees accounted for. So we know that the 3 angles add up to be 180. I'm going to subtract my 100 to get 80 degrees left for my remaining unknown quantities. Well, I have 5 of those unknown quantities. So I'm going to take my 80 and divide it by 5 to get 16. So that means each of my unknown quantities are 16. So I have one angle that measures 90 degrees. I have one angle that measures 16 degrees. And then my other angle is going to be 4 16ths plus 10 to give us a total of 54. So our angles are 16 degrees and 54 degrees. And there we go. Again, if we wanted to solve it algebraically, we could set it up using an algebraic equation to show how the tape diagrams work. Okay, I'm running out of time, so we have a limit to 10 minutes, so I'm going to go on ahead and go. Please excuse my cold, but thank you, and I appreciate your time, and look forward to working with you more as we move through the program. Thank you.